Good morning, everybody. Happy Monday. Welcome to another week. Jumping into another video on linear relations. And what we're doing this week is actually looking at the equations. So we've kind of really just looked at slopes so far. And now what we're going to do is look at the equations and the graphs and all of that and build with our idea of linear relations. So with that said, let's hop into the video. Page 553 in the workbook, which is a bit of a jump ahead from our last lesson. Technically, this unit is split into two chapters, so this would be the start of that second chapter. And we're looking at equations of linear relations. And specifically today, we're talking about the slope y-intercept form, or I just call it slope-intercept form. And it looks like this. This is actually something we would have looked at in grade 9. And a lot of what we're doing for the rest of the unit is similar to grade 9 with some added detail, right? We had a linear relations unit last year. This is just taking it to the next step. So let's look and talk about some graphs. Okay, I'm just going to jump in and talk a bit more about why we're looking at linear relations this year very quickly. And then we'll get to those graphs in the workbook. So the majority of things in life and graphs we look at and all of that are actually not straight lines, right? It's a very perfect world when you actually get something that can be represented by a straight line. It happens a lot of the time, but then there are even more so situations that are curved or have bends or whatever. But the reason we study straight lines is because they're the basis for everything, and they actually represent situations a lot better than you would think. So I've got this graph. It's really wonky, right? It goes up, down, and it's curved, right? It's not flat. It's not a straight line. But the thing is, if I zoom in on a section, so if I look at this section right here, okay, it's curved. Well, the closer I get to that, and as I look at this moment, okay, it's curved. As I start looking closer and closer, and as I focus in on one specific moment, this is starting to look like a straight line and a straight line and a straight line. So can a straight line represent a vast situation? No. But what we can do is we can use the straight line to represent specific moments of things and specific trends and how do things go up, how do things go down, all of that stuff. So that's why we focus so much on linear relations, especially at an early stage, is everything can kind of be based on them, and they have a lot of building block skills. And at the end of the day, even a really curved surface, if I look at a very specific moment, can resemble a straight line. Okay, let's jump back to the workbook. Okay, so first thing we're going to look at is deciding if it is a linear or nonlinear relation. And really what it comes down to is linear would be something that is a straight line on a graph. Nonlinear would be anything other than just a straight line. Okay, so there's 8 graphs, and we're going to go through and make quick sketches. So I'll do maybe one of them, and then I'll let you go ahead. Okay, 3x plus 1 on my graph, and I'm going to go zoom 6 or zoom standard. Okay, and it looks like that. So in terms of putting that on my graph, looks something like that. And that's a straight line. I would say that one is linear. Okay. And then we'll go through 1, 2, you got 7 left. And just a quick sketch, right? Like mine's not perfect, but it kind of gets the picture there. So go ahead of me, pause the video and do all 7. And then down below, you can kind of say, okay, well, which one of those were linear? Which one of those were not linear? Okay, so go ahead and pause.
A few moments later.
All right, so those are my quick sketches of all the graphs. Hopefully you got something similar. These were just a quick sketch, and then we'll talk about them a bit. So in terms of which of these are linear and then which are nonlinear, well, okay, y equals 3x plus 1. That one was a straight line. The next one, y equals negative 2x plus 3. That was a straight line. It's linear. The third one, negative x cubed plus 1, is non-linear. It's like an S maybe, or it's like a squiggly line. That thing is definitely not linear. It's non-linear. And same thing with x squared minus 3. It's like a U. It's a scoop. That name is parabola. Okay, y equals 1 over x. No, that one was no good. That's like kind of two separate pieces. Y equals 1 half x minus 2. Oh, that one was a straight line. 1 half x minus 2. 4x, that one was good. It was a straight line. And then the final one, 2 to the power of x. Well, that one was no good. It's like a big swooping curve all the way up. Okay, so I'm looking at these lists and I'm looking at which of these equations gave me straight lines, which of them didn't. Okay, and what I want to notice is for all of these top ones, all of the ones that were linear, those would be polynomials of degree 1. It's just an x, an x, an x, an x. It's not x squared. It's not x cubed. It's not x to the negative 1. Those are simple polynomials to the degree of 1. Okay, so it's just an x. It's not x squared, x cubed, x to the 4, whatever. For our linear equations, we're just dealing with an x. Okay, let's go on a little bit more. A linear equation is an equation of the form y equals mx plus b. This is going to be really important, where m and b are element of the real. So really all that's saying is, yeah, I have my y and my x, and then I'm multiplying. I have some value in front of the x, and I'm adding some value on the end. Okay, that is called the slope-intercept form, and we're going to touch on that a little bit more. Okay, so let's look at mx plus b, and maybe I can figure out where those values come from, or maybe you remember from grade 9 or whatever. Okay, Janine used a graphing calculator to sketch the graph of the line 2/3 x minus 1. Her sketch is shown on the grid. All right, there it is. Use the sketch and points A, B to find the slope and y-intercept. So I would say slope. I can count. Maybe I use the slope formula, or maybe I just say from A to B, you go up 2 over 3. Rise over run, that would be 2/3. Okay, that's a really weird looking 2. 2/3. Okay, in terms of the y-intercept, okay, well, that would be point B, actually. Where do I cross the y-axis? 0, comma, negative 1. You have a y value of negative 1. Okay, and then I'm thinking, it says compare the values that I just found with the coefficient of x and the constant term in that equation. So, y equals 2/3 x minus 1. And what I'm trying to explore is this mx plus b idea. And then you're probably thinking, well, hey, slope, didn't we use the letter m to represent slope? So absolutely, that m value, that 2/3 we found, is the coefficient in front of the x, right? That m is slope. We use m for slope. That's why it's the letter m. It's there on purpose, okay? And you think, okay, well, what about the b? Well, the b value is negative 1. Oh, that was my y-intercept. Huh, that's pretty interesting. Okay, we're going to go a bit further, and then I think we'll be able to make a claim. Okay, 2 more equations. Y equals 2x plus 1 and negative 5 halves x minus 3. So for the first one, the slope is, well, I've kind of got these 2 points here. I go up a whole bunch. Up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. So my slope would be 8 over 4. Oh, that's just 2. Ah. My y-intercept, it's kind of in the middle, is, here's the origin. So 1. Y equals 1. Okay. Let's go to the next one. I have my 2 points. I go down 1, 2, 3, 4, 5 over 2. Negative 5 over 2. That would be my slope. Oh, that's a familiar number. Y-intercept is actually that second point. It happens at a y value of negative 3. Okay, and I think we're able to make that same connection. The slopes were that coefficient of x. 2, 2, negative 5 halves, negative 5 halves. And then this constant on the end, well, that's just my y-intercept. Okay, so if I'm looking at this equation, y equals mx plus b, M is going to tell me my slope, and B is going to tell you your y-intercept. So if I have an equation that looks like that, y equals something times x plus a constant, I know two really important pieces of information. Okay, so this, I think we maybe know from grade 9. Maybe we forgot, but we should know. Okay, is an insanely valuable equation. If I ever have something that looks like this, I know the slope and I know the y-intercept. Okay, for a straight line or for a linear relation. Okay, and then I look at this. Okay, Hashib used a graphing calculator to graph the linear relation 2y equals 5x plus 8. And there it is. Okay. Well, maybe a little bit skeptical, but let's go through the questions. Use the sketch to determine the slope and y-intercept. Okay, slope, m equals, well, let's go point to point. 1, 2, 3, 4, up 5, oops, over 2. My slope is 5 over 2. And looking at that equation, the number in front of the x is 5. Well, that's not good. Okay. The y-intercept, okay, is, the top point. It's 4. Okay, a y value of 4. And you'd say, well, wait a minute. That's supposed to be the constant, and it's an 8. Okay. And that's what it gets to in B, is to explain why that is not the case. Well, the reason is the equation is y equals mx plus b, not 2y equals mx plus b. So what I'd have to do, and this is what we're going to do a lot of, we're going to manipulate equations and rearrange equations, is say, algebraically, I don't want to solve for 2y, I wanted to just solve for y. So the opposite of multiply by 2 would be to divide by 2. But if I'm going to divide by 2, I'm dividing this whole side. Okay, so you'd get y equals 5 divided by 2, that's just a fraction, 5 halves x. And then 8 divided by 2, well, that's a whole number, that's plus 4. And if I look at this form, yep, I got a slope of 5 halves. And my b value, my y-intercept, equals 4. Okay, so remembering, I can only use this idea of y equals mx plus b when it's y equals. It can't be 2y or 3y or 4y. I have to rearrange first before I can use it. Okay, so this form, I think I even said this at the start, is called the slope. They call it slope y-intercept. I just call it slope-intercept. Okay, slope-intercept form is y equals mx plus b. Super original name. We call it the slope-intercept form because it tells us the slope and it tells us the y-intercept. Okay, and that's going to be super, super useful. Okay, first question, it says determine the slope and y-intercept of the graph listed below. So I don't have to graph it, I don't have to do anything. Okay, slope equals 3. Y-intercept equals 2, positive 2. I'm done. And maybe, right, maybe I'd write that as 0, 2. I'd write it as the ordered pair, or I'd write it as y equals 2 or b equals 2 or whatever. Okay, B and C. Well, I look at those, and just one thing to keep in mind is I want it to look like y equals mx plus b. So right now, this is b minus mx. So I'm going to rearrange. I'm going to put that 2/3 x, the negative 2/3 x up front, and then I'd have my plus 7. And then from there, it's a little bit easier to say, okay, your slope equals negative 2/3, and then your b value equals 7, or, right? There's a lot of ways I could write this. B value of 7. I could have also gone with this and said the y-intercept equals 7. I could have also written it as a coordinate pair. There's all sorts of way for me to write that. Okay, last one, 6y equals 8x plus 1. Well, this is the same situation we just looked at. I need y equals. I don't want 6y equals. So algebraically, you have 6 times y. The opposite of multiply by 6 would be divide by 6. Okay, and that's what I'm going to do. Y equals 8 divided by 6. That's going to be a fraction. right? 8 6 that doesn't divide perfectly, plus 1 x, sorry, 8 6x plus 1/6. And then I always look to reduce my fractions. Those are both divisible by 2. So I'm really going to write this as 4/3 x plus 1/6. And now from there I can say, okay, slope 4/3, the reduced fraction, your b value, positive 1/6. There you go. Okay, so from these equations, I already know two pieces. I know the slope and I know the y-intercept. That's super, super valuable. It allows me to do a lot of things. Okay, understanding this form is going to be super useful for us as we do more and more things. Okay, last thing we're going to look at today is, hey, can I graph something and can I do it maybe without my calculator, right? We know how to graph with our calculator. We know how to make a table of values. We know how to kind of work around and do things like that. Well, I'm going to tell you it's a lot easier to graph using this slope-intercept idea. Okay, it's going to be a lot quicker than going to your calculator, a lot quicker than building a table of values. Okay, because if I look at this, consider the equation y equals 2x minus 5. Well, I know the slope, right? The slope is 2. Okay, and in terms of y-intercept, the y-intercept is negative 5. So as a coordinate pair, that'd be 0, negative 5. And if I want to graph a straight line, I know this is a straight line because it has a degree of 1. All I need to make a straight line is 2 points. Yeah, normally when I graph, I look for 3 or 4 or 5, but technically all I need is 2 points. And I already have one of them. 0, negative 5, my y-intercept I can put on my graph. And then we did this actually when we talked about slope. I can find another point using that slope. Slope represents rise over run. So when I look at a slope of 2, well, I'll change that to a fraction. I'll say 2 over 1, because now I can talk about a rise of 2, a run of 1. So from my existing point, rise 2, run 1. Hey, you found a second point, right? Immediately I could connect these points and I could say, we're good. You have a straight line. Maybe I'll go a bit further. Rise 2, run 1, put another point. Maybe I go back the other way and I say, okay, the opposite would be down 2, back 1. And I could connect these all the way. And then here's where I get out my ruler. Okay. And I try to connect a straight line. Yeah, pretty good. And then I make sure to put arrows on both ends saying, hey, this thing goes on and on forever. I just don't have enough grid space to actually show that. Okay. There it is. It's that simple, right? I need 2 points. My 2 points would be my y-intercept and then use the slope to find the other one. And then I just find extra points just for, reassurance to make sure everything lines up. But really all I needed was those first 2 points. Okay, verifying the graphing calculator. Sure, let's do that real quick. 2x minus 5. I'll go zoom 6. Hey, there it is. Okay, looks pretty similar to what we have. If I wanted to find second calc value, find the y-intercept, negative 5. Yeah, it looks pretty much the same. Okay, and I think I'm good to go. All right, the last question for today is the exact same thing we just did. Well, I guess the only extra thing is this one wants you to mark the x and y intercepts, and we didn't do that above. Oh, and determine it. You can do that. You know what? Do this whole question ahead of me, and then I will follow up with the answer.
1 hour later.
Okay, I've gone ahead and done a little bit on this question, and then so hopefully you've done it ahead of me, and then we'll make sure we're doing the same thing. So it says consider that equation, state the y-intercept, and then 0, negative 6. I plotted that on there. And then it says determine the x-intercept algebraically. Okay, well, that's something from last unit. I know the x-intercept happens when y equals 0. So I took that original equation and plugged it into 0 and then solved, right? Add 6 to both sides. Okay, good. Multiply by 3, good. Divide by 2, good. And I get that intercept of 9. So that would be, I could plot that, right? I can put that on my graph. But what I think an easier way to graph this thing would have just been to say, okay, I know the y-intercept and I know the slope is 2/3. And what I'm going to show is if we just move up with the slope, we're going to get to that x-intercept. Okay, we're going to find the same point. So I would go up 2 over 3. Up 2 over 3. There's my next point. Rise 2, run 3. Up 2 over 3. And one more time. Oh, would you look at that? Right to my x-intercept. Okay, I could have gone the other way, down 2, back 3. But it's ultimately the same thing. Connect my straight line, put some arrows on it, and I'm good to go. Okay, so yeah, I have the y-intercept. Maybe I find the x-intercept algebraically and just connect those points. Or what I think is easier is just to do it with the slope and counting the slope. Okay, it says to verify on your calculator, so let's do that real quick. Okay, y equals 2/3. Okay, so I'm going to have to enter a fraction, which I do with brackets. 2/3 x minus 6. Go to my graph. There it is. Finding the y-intercept, I enter an x value of 0. I get -6. Good, I already knew that. Finding the x-intercept, I have to do a 0, right? Left bound, am I to the left of the intercept? Well, I'll move a little closer, but I'm already to the left. Yes. Am I to the right? I got a lot of tapping to get there. Am I across the x-intercept? Yes, now I am. Enter. And make a pretty good guess. Hey, x equals 9. There you go. So I was correct a lot faster with my, doing it by hand than I would have been using my calculator. And that's it. Okay. So we got a little bit of homework. We got to check for understanding. We're going to spend more time with this y equals mx plus b tomorrow. And then we're actually going to learn a couple different forms of the equation that are, useful in different ways and provide different information. So there's your homework, 2, 3, 4a, 7, and 10. And you got to check for understanding as well. And there you have it. Another video done. So you got a little bit of homework to do. You got to check for understanding today. And then all of the normal stuff, right? Set up a one-on-one appointment, ask your questions in the form, and yeah, make sure you're staying on track. So smash the like button, hit subscribe, all of that, and tune in again tomorrow for another video.